All right. Get ready to dive deep into functional programming, but with a bit of a spooky twist today.
Oh, this should be fun.
Yeah. So, you guys have been sending us these excerpts from this blog series.
I've seen this one.
Dr. Frankenfunctor and the Monadster.
Yeah.
And it's amazing. I mean, the author, Scott W., he uses this really creative analogy to explain monads in FTAR.
It's actually brilliant, I think, because monads, they can be kind of a head scratcher.
Oh, yeah.
For a lot of people. But this metaphor of Dr. Frankenfunctor building this monster from all these different parts, I mean, it makes it so much easier to understand.
It really does. So, okay, just picture this Dr. Frankenfunctor's in his lab, right? And he's surrounded by all these, let's just say, spare parts.
Right.
And his mission is to build this creature, the Monadster.
Okay.
But like any good mad scientist, he's got a limited supply of vital force to work with.
Right.
Think of that as your data in programming.
So just in very simple terms, a monad is a design pattern that we use in programming to help us chain operations together while keeping side effects in check.
Yeah.
Got it.
It's kind of like a container for your data and your functions.
Right.
To make sure everything happens in the right order.
So it's like a recipe for making a monster, but an organized one.
Exactly.
Okay, so in part 1 of this blog series, Dr. Frankenfunctor, he's tackling the monster's left leg and arm.
Right.
And, of course, there are some hiccups along the way.
Yeah, of course. I mean, it wouldn't be a good story without a few hiccups.
Right, exactly. So the blog starts with the left leg, and Dr. Frankenfunctor, he finds well, let's just call it a pre-loved leg.
Sure.
And he needs to combine it with that vital force to, bring it to life.
Yeah, you can't just plug it in. You gotta do a little work.
Right, there's a whole process involved.
Right, and that's where the M type comes in. This is kind of a key concept here.
Okay.
It acts like a blueprint, a function really, for turning a lifeless part into a living one.
There's like a set of instructions. Take one lifeless leg,
yeah,
add vital force, boom, living leg.
That's it. That's the recipe.
But then, as Dr. Frankenfunctor's patting himself on the back, he realizes there's no right leg to be found.
Oh, no. This is like a classic programming problem. You've got your plan, you've got your code, and then bam, missing piece.
Exactly. And it just shows you how important adaptability is, in programming.
Right.
You always have to adjust and find workarounds.
Speaking of workarounds, it looks like the left arm is, wait for it, broken.
Oh, no.
Dr. Frankenfunctor can fix it, but only after it's alive. So how do you even do that within this M recipe context?
So that's where the mapM function comes in.
Okay.
And think of this as applying a transformation, like in this case, healing, within that M blueprint.
Okay.
So it's like saying, make the arm live and then heal it.
Okay, so you're doing something after that initial transformation.
Exactly.
And I can already see how this would be useful in like real coding scenarios.
Absolutely. It's all about controlling the order of operations.
Right.
mapM is especially handy when you're dealing with operations that might have side effects. And you want to make sure that those side effects happen at the right point in your code.
Now, speaking of side effects, I think Dr. Frankenfunctor had another problem, didn't he?
Oh, he did. It turns out there's no right arm either.
Oh, geez.
This time, though, he does have a lower and an upper arm.
Okay.
So the question is, how do you combine two separate M recipes?
It's like he needs to perform surgery within the recipe itself.
Yeah, and that's where map2M comes in.
Okay.
This function lets you merge those two M recipes.
All right.
The one for the lower arm, the one for the upper arm, into one recipe for the whole arm.
So you're basically combining those smaller recipes into a bigger one.
Exactly.
And I noticed in the blog post that Scott W. actually includes a little snippet of F# code showing how map2M works.
Yeah, he does. It's really cool because you can actually see how these concepts translate into real code.
Yeah.
So, he defines a type called body part.
Okay.
To represent the different body parts. And then he uses map2M to combine the recipes for the lower and upper arm. And he applies this function called attach to connect them together.
So you're not like manually stitching things together. You're using code to do that.
Exactly.
That's pretty neat.
And that structure is really important because it makes your code predictable and consistent.
This whole analogy is making me see functional programming in a totally different light. It's less of little composable blocks.
Yeah.
It's like Legos for programmers.
I love that that's a great way to think about it.
Yeah, so we've got a left leg and a patched up left arm.
Right.
But what about the rest of the Monadster?
Well, that's for next time.
Stay tuned, because in part 2, we'll be tackling the torso and the all-important head.
Things are going to get even more interesting.
I have a feeling they are.
So we get our left side put together, kind of, but now let's move on to the torso.
The torso.
which you would think would be fairly straightforward, right?
Yeah, it seems like it should be. I mean, according to the blog, Dr. Frankenfunctor, he has all the necessary parts, the chest ribs spine.
Right, the whole skeletal crew.
Yeah.
But of course, there's a twist.
Uh-oh.
He can't just slap them together all willy-nilly.
Right.
Each part needs that jolt of vital force before it's connected to the others.
Okay, so it's like each piece has its own little M recipe to follow.
Exactly. It's not like one big build a torso recipe.
Right.
It's more like make a chest, then make ribs, then make a spine.
Uh-huh.
And then you figure out how to Frankenstein them all together.
Right. So how do you do that?
Well, that's where this concept of sequence M comes in.
Sequence M. Okay.
Yeah. Think of it like an assembly line.
Okay.
For those individual M recipes,
yeah.
making sure each step happens in the right order, passing that vital force down the line.
Okay. I'm picturing like a conveyor belt of body parts.
Exactly.
Each one getting its little zap of life as it moves along.
Yeah. It's a very efficient system.
That's pretty cool.
Yeah. So basically, sequence M takes that list of individual recipes, chains them all together, manages the flow of that vital force, or data, as we would call it, in the programming world.
Right.
So you don't end up with like a half-animated torso or something.
So you're saying the output of sequence M is essentially one single M recipe for like a complete living, breathing torso.
Exactly.
That's pretty slick. I mean, in the real world, where would you actually use something like sequence M?
Oh, that's a great question.
Yeah.
Think about any scenario where you need to perform a series of operations.
Right.
In a specific order.
Right.
And each operation might have some kind of side effect. So maybe you need to read data from a file, then process it, and then write the results to a database.
Okay.
Sequence then would let you encapsulate each of those steps as an M recipe.
Got it.
And then execute them sequentially.
So it's really not about building monsters. It's about managing those complex workflows.
Exactly. Make sure that each step completes successfully before you move on to the next one.
In a way that's reliable and predictable.
Exactly. And what's really neat is that sequence M isn't limited to just torso parts or anything.
Yeah.
You can use it with any list of M recipes.
So theoretically, Dr. Frankenfunctor could use this to build a whole army of monadsters.
Well, in theory, yes.
Oh, boy.
It's a slightly terrifying thought.
Yeah, just a little bit.
But it really highlights the power of this concept. You're creating a blueprint for constructing complex entities in a very structured and repeatable way.
All right, so torso assembled.
Yeah.
But what about the head?
The head.
I mean, that feels pretty critical, the brains of the operation and all.
It is. And, it's, as you might expect, it's not as simple as just plopping a brain into a skull.
Oh, no, of course not.
The blog post says that Dr. Frankenfunctor has both of those parts, but no obvious way to connect them.
Another missing link.
It seems so. But this time, the solution isn't about, physical stitching. It's about transforming the brain into a format that's compatible with the skull.
So instead of forcing the pieces together, you're changing the data itself to make it fit.
Exactly. It's like needing the right adapter for your data.
Clever.
And this is where the bindM function comes into play.
bindM. All right, I'm ready.
This one is really cool. bindM lets you chain together those M recipes.
Okay.
Where the output of one becomes the input for the next one.
So it's like saying, take this brain, apply a recipe to morph it into a brain-skull connector.
Yes.
And then apply another recipe to attach it to the skull.
You got it.
Nice.
bindM is really key for those scenarios where, one step's outcome dictates what the next step's going to be.
So it's not just a linear assembly line anymore. It's
it's much more dynamic.
Dynamic workflow.
Exactly.
I like that. So it's less like following a set of Lego instructions and more like navigating a choose-your-own-adventure book.
I love that analogy. That's perfect.
But for monster building.
For monster building, yes. And that's the beauty of these functions. mapM, sequence M, bindM, they give you so much flexibility to handle all sorts of complex situations, but in a way that's still structured and predictable.
This is making me think about code structure differently. It's not just a series of commands. It's like this network of possibilities.
It is.
Each one, depending on the one before it, it's like elegant almost.
It is quite elegant. And that elegance is really a hallmark of functional programming. It lets you build these really complex systems in a way that's powerful but also maintainable.
Okay, so we've got the legs, the arms, the torso, and now even a head.
We do.
It sounds like Dr. Frankenfunctor is getting pretty close to having a complete monadster.
He is.
Yeah.
But the big question remains, will it all come together? Will the monadster walk?
Ooh, cliffhanger.
Join us for part 3. as we explore that final stage of this monster-making process.
Okay, so it's the moment of truth. We've got all the parts of our monadster laid out, legs, arms, torso, even a head. But can Dr. Frankenfunctor actually bring this thing to life?
Well, this is where things get really interesting, like conceptually speaking.
Okay.
So, each of those parts, once they're assembled, they exist as an M-type, right? That recipe we've been talking about.
Right.
It's like an individual blueprint waiting for that final spark of vital force.
Okay, so how do we take those separate recipes and merge them into one big make a monster recipe?
Right.
You can't just stack them on top of each other, can you?
Not quite. It's not about simple addition here. This is where the idea of composing monads comes in.
All right.
Specifically, this idea of nesting them.
Nesting.
Okay. And in the blog post, Scott W., he uses this function called joinM to illustrate this.
joinM. Okay, sounds intense.
It's very powerful.
So what does it actually do?
Okay, so imagine you have a box, right? It's labeled M.
Okay.
And inside that box is another box also labeled M. And inside that box is your actual living, breathing body part.
Okay.
What joinM does is it collapses those boxes down into a single M box containing that body part.
So you're flattening those nested recipes.
Exactly.
It's like those Russian nesting dolls. You keep opening them up until you get to that tiny little one in the middle.
That's a perfect analogy.
But in this case, you get to the instruction set for the whole monadster.
Precisely.
Wow, okay. But if it's like a whole monster, wouldn't we need to use joinM multiple times?
You're absolutely right. And that's where another function called liftM comes into play.
Okay, liftM, what's that do?
Well, liftM basically takes a regular function and adapts it to work in the world of monads.
Okay.
So instead of physically stitching those body parts together, you're using liftM to combine the recipes for those body parts.
Got it.
Into one unified set of instructions.
And this is where that analogy, I think, becomes really powerful.
It is.
It's not just about writing lines of code. It's like you're creating these building blocks that can be combined and recombined in all these different ways.
It's like Legos for programmers.
I love that analogy because you can take bricks from different sets and build something totally new.
Exactly.
I never thought about code that way before.
And just like with Legos, the process is really systematic and predictable.
Yeah.
That the final outcome is going to be what you intended as long as you follow those building instructions.
Or in this case, our functional composition rules.
Right, exactly.
Okay, so big picture time. This isn't just about some crazy scientist and his monster.
No.
It's about managing complexity in programming, isn't it?
It really is. Monads might sound scary and advanced, but they're really just a structured way to handle complex operations, making sure that each step happens in the right order with the right data.
Right.
And ultimately that the final result is what you expect.
So final question, does Dr. Frankenfunctor actually succeed?
Well, Scott W. very cleverly leaves that to our imaginations.
Oh, come on.
But I think the real takeaway here is that we've seen the entire process.
Yeah.
From those individual body parts to that complete creature, all through the lens of monads and functional programming.
It's amazing how this monstrous analogy can make something so complicated.
I know, right?
So clear.
That's the beauty of a good analogy.
Right.
It takes something that's very abstract and makes it relatable,
Yeah.
something you can really visualize and grasp.
This deep dive honestly has changed the way I think about coding.
That's awesome to hear. I mean, that's what we're here for.
So next time you're facing a coding challenge that feels like a monster,
Yes.
remember Dr. Frankenfunctor.
Break it down to find those recipes.
Yeah, use the power of functional programming to bring it all together.
Yeah.
You might just create something amazing.
You never know.
This has been a fascinating exploration of monads and functional programming. Thanks for joining us.
Absolutely. And until next time, keep experimenting, keep learning, and keep coding.
Who knows? Maybe there's a monadster lurking in your code just waiting to be brought to life.